In next few minutes, a simulation model will be presented to you. It was created according to usual process each person has to go through in the canteen before he can eat his meal. If you are not one of the first people that arrive to the canteen, you usually have to wait about 10 to 30 minutes in the row before you can choose your meal. We wondered if the process could be optimized. For 4 days, we have been collecting data needed to create the simulation model of the canteen. Then we made experiments to achieve shorter waiting time. At first, a person enters the canteen. As you can see, the person has some characteristics which determine his decisions. It means that in this case the person, with identificator equal 1, decides he doesn't want a soup, so he will not take one. Meanwhile, 6 soups are ladled by someone from the canteen personnel. Next 3 people also decide that they don't want a soup. 5th person wants a soup, so he takes one. Now there are 5 bowls of soup left for other people. 6th person also wants a soup, but, before taking one, he has to wait for previous person, since taking a bowl of soup takes some time and no more than one person can take the soup simultaneously. This scenario repeats over and over for all the following people. Based on their decisions, represented by the soup chance characteristic, they decide to take a soup, or not. Here we have the first person again. He decides that his main course will consist of 2 parts. As first, he will choose an attachment, which takes him approximately 13 seconds, then he chooses meat as the second part of his main course. By the time second person decides he also wants an attachment to his meal, choosing the type of meat together with serving the meal, takes approximately 21 seconds. The second person has the attachment served, and decides he wants to have fish as the second part of his main course. Then he chooses which kind of fish he wants, and has his fish served, which takes approximately 31 seconds. This repeats until 9th person chooses steamed buns and orders them, which takes no time, and he goes straight to payment. Someone of the canteen's personnel who is free will prepare the buns, which takes him approximately 84 seconds. People keep choosing and ordering their meals, and some of them choose meal from back counter. This takes about 37 seconds. When it comes to payment, a cashier has to register people's meals first. This takes approximately 8 seconds. Then about 87% of people want something more to be added to their order, so the price of their order will fulfill a particular amount. Then the person pays his order. The first person uses Isaac card to pay, however about 33% of people in the canteen pay with cash. According to our simulation experiments, we recommend to reorder the meal counters, so each meal's serving time would be shorter. Changing meal counters' position wouldn't cost as much money, as for example hiring new personnel. As you can see on the graph, if each meal's serving time is shortened by 10%, average waiting time could be possibly reduced from 15 minutes to something over 12.5 minutes, and average maximal waiting time is shortened from almost 28 to almost 23.5 minutes. In the case of reducing serving times by 20%, average waiting time is reduced by almost 5 minutes, and average maximal waiting time is reduced by almost 9 minutes. If we reduce the serving times even more, both average waiting time and average maximal waiting time would of course keep reducing, but not very rapidly. Thank you for your attention.